Hello, everyone, and welcome to Math 3. This is Section 2, 1.2 Solving Inequalities. So, what we're going to talk about today is how to solve an inequality and a compound inequality. So, an inequality is something that is not equal to another part. So instead of an equation where one thing equals something else, an inequality is when something is not equal to another part. Okay. And we have our inequality symbols here. So this first one is a greater than. So that means greater than. Our second one means greater than or equal to. Remember, that line underneath the greater than sign gives us the equal to. Our third one means less than. Our fourth one means less than or equal to. And those are our four inequality signs that you need to know. Greater than or equal to, less than, and less than or equal to. Now, as we move up, less than is the same as left on the number line. Makes it L. So if you're thinking about going left on the number line, that is less than. Reminder that you always want your letter on the left side of the inequality. So if you finish the problem and your letter is on the right side of the inequality, then what you need to do is just look at it and say, let me move it over to the left, okay? So 4, this is 4 is less than x, but you see how the arrow is pointing there? Move the x to the left side so it really is x is greater than 4. A lot of people miss this and put less than, but it is a greater than inequality. So it is x is greater than 4, just like this one is x is less than negative 2. So these are two that you can get mixed up if you don't keep your variable on the left. These four ways determine the way you shade, so which way you shade the inequality, and whether your point is an open circle or a closed circle. So less than, greater than, less than or equal to, and greater than or equal to determine the way you shade on the number line and whether you have an open circle or a closed circle. So we're going to show you some here. X equals negative 2. That would be a closed circle at negative 2 because it equals negative 2. It's not less than or greater than or anything. Let's look at the next one. X is greater than negative 2. That would be an open circle because it's greater than, means it doesn't include that number. Open circle at negative 2. And greater than means I shade to the right. So I'm going to shade all the way to the right and then shade in that arrow there. So that's x is greater than negative 2. Go to the third one. X is greater than or equal to negative 2. It's the same as that one above, except I shade in the negative 2. So it's a closed circle. So x is greater than or equal to negative 2 means I shade all the way to the right, greater than or equal to. Now I'm going to scroll down. X is less than negative 2. We put an open circle at negative 2 and we shade to the left because it's less than negative 2. Remember, less than means to the left on the number line. And then lastly, x is less than or equal to negative 2. That'd be a closed circle at negative 2 and again shaded to the left. So the only difference in what makes it a closed circle or an open circle is whether it has equal to or not. If it has equal to, then that means it's a closed circle. If it has just less than or greater than, that means it's an open circle. Remember, less than points to the left and greater than points to the right. Okay, so that takes you through the first part here. Now we're going to go to examples 1, 2, and 3. Example 1, write the inequality for the following graphed below. We'll look at this one. If we kind of zoom in on this one a little bit, you see that this inequality down here is at -2, and you are shading to the right. It's an open circle at -2, so that would be x is greater than -2. We see this one, we have a closed circle at 8, and it's shaded to the left, so that means x is less than or equal to 8, because of the closed circle gave us the equal to, and pointing to the left gave us the less than. Here it's going left, and it stops at 2, and it's an open circle, so that would be x is less than 2. So the open circle means it's not the equal to, it's just less than, and is pointing to the left. So there's the first sheet of your notes. If you'll turn with me to the second sheet. On the second sheet of the notes at the top, you see a couple examples of inequalities. So example number 1 is 3x plus 4 is greater than 25. Step 1, you would subtract 4. So that gives us 3x is greater than 21. And then step 2, you would divide by 3. So that gives us x is greater than 7. And that is our final answer. Okay, let's go to example number 2. Negative 2x minus 9 is greater than 15. Step 1, we want to add 9. So we get negative 2x is greater than 15 plus 9 is 24. And then in step 2, we want to divide by negative 2. When you divide by a negative, it is going to flip your inequality sign. So instead of greater than, look at what happened. It changes to less than. So 24 divided by negative 2 is negative 12. And that is a rule that whenever you multiply or divide by a negative in inequalities, it flips the sign. So you should have seen that in an earlier math class. But if not, there it is again. And that's example 2. A couple things to remember on here. Things you want to remember: parentheses and the distributive property. You want to remember to simplify the left and the right side of the inequalities. You want to remember to move the variables to the left side. That means move the x's over to the left, move your numbers over to the right. You want to add and subtract to get your numbers there in order. And then at the end, you want to multiply or divide. So if you have a number right beside x, you want to divide by that number to solve. Okay, so here are some inequalities to solve here at the bottom. And we're going to look at these. And remember, it says one rule to remember: when you divide or multiply by a negative number, you switch the inequality symbol. And that's what we did up there in example 2. So let's look at example number 1. Negative 17n is greater than or equal to negative 204. So in this one, the only thing we need to do is divide by negative 17. And notice that is going to change our sign. So instead of greater than or equal to, it's going to be less than or equal to. Now I'm going to take my calculator, and I'm going to say negative 204 divided by negative 17. And that's going to give me 12. So I've got n is less than or equal to 12. That's answer number 1. We go over to example 2, and I'm going to divide by 10. So I've got negative 200 divided by 10. That gives me negative 20. Now, my variable is on the right side, so I want to move it over to the left, right? So I'm going to say m, and look at the way it was pointing, is greater than or equal to negative 20. That's example 2. In example 3, all I'm missing here, it says negative 17 plus n is greater than or equal to negative 14. I'm going to add that to the right side. So I'm going to say plus 17. And so I get n is greater than or equal to negative 14 plus 17 is going to give us 3. Over here, I have n plus 3 is greater than negative 1. So I'm going to subtract 3 to get n by itself. Negative 1 minus 3 is negative 4. So negative 4 is less than n. Remember, my variable's on the right side. I want it to be on the left. So n is greater than negative 4. Good example 5. We are going to subtract the 7 to the right side. We get negative 8k is greater than or equal to negative 88. And then we want to divide by negative 8 here. Let me get where you can see this again. We want to divide by negative 8. When we divide by a negative, remember, we're going to flip the sign. So k is now, instead of greater than or equal to, it's going to be less than or equal to. Negative 88 divided by negative 8 is 11. And so we get k is less than or equal to 11. We go to example 6. First thing we're going to do is add 5. Negative 4 plus 5 is 1. So 1 is less than or equal to b over 10. When we have a number on the bottom and we want to get rid of it, we have to multiply. So we're going to say times 10. So we're going to say 10 is less than or equal to b. And our variable's on the right side. We want it on the left. So b is greater than or equal to 10. We go to our last two examples. Example 7. Negative 4n minus 2n is negative 6n. And we can add this 1 over here. And negative 1 plus 1 is 0. So then we can add 8n. And we get 2n is less than 0 because there's nothing left over there on the right side. And then we divide by 2. 0 divided by 2, well, really 0 divided by anything, but definitely 0 divided by 2 is still 0. So n is less than 0. So be careful there that you don't put no solution. A lot of people, when they see they just have the variables, they will go quickly and write no solution. But there is a solution. The solution is n is less than 0. Okay? And our last example over here, we're going to distribute the 8. So we have 2 plus, we're going to say 8 plus, and then 8 times 8m is 64m. Then over here, we have 10 plus 4m. So 2 plus 8 is 10. And 10 over here as well. So we will subtract the 64m. We'll get negative 60m. And we will subtract the 10 to this side is greater than 0. So negative 60m is greater than 0. We'll divide by negative 60. Anytime you divide by a negative, you flip the sign. So m is less than, so it goes from greater than to less than 0, because 0 divided by anything still gives us 0. And that is example number 8. And that was your last example on this sheet. So that is inequalities. So that's solving inequalities. The next section in Math 3 is absolute value inequalities. So this kind of sets you up to work through some absolute value inequalities. So if you have any questions, go back in this video, look back at the questions that I worked out, and you may now continue to the assignment on inequalities. Thank you and have a great day.